Okay, guys, so this is the lecture from section 11.4. Section 11.4 is about slope-intercept form of linear equation. Okay, so slope-intercept form. So let's start with definition. Slope-intercept form is the one y equal mx plus b. So that's the one which most students knows, where m is a slope and b is the y-intercept. So b being y-intercept, that means it's a point 0, comma b. It's the point on the y-axis. Okay, so let's do an example. Identify the slope and the y-intercept. Okay, so we're going to do a couple examples. Let's do A. We have y, it's equal 4x plus 6. So here we don't need to do anything because this equation of a straight line, it's in a slope-intercept form. So slope, it's the coefficient in front of x, which is 4. And y-intercept is the number okay. So y-intercept, in this case our b, it's equals 6, which means we have a point 0, comma 6. Okay, so let's do example b. In b we have y, it's equal 3.5x minus 4.2. So this equation is in the slope-intercept form. So we need to identify the slope. So slope, it's coefficient in front of x, which is 3.5. And the y-intercept, it's always the number which stands by itself. So, and we of course take the sign which is in front of that number. So the y-intercept is negative 4.2, which means we have a point on the line 0, comma negative 4.2. That's the y-intercept. Okay, and let's do C. We have y equal negative 7. So here you don't see x, so this is the horizontal line. Okay, so horizontal line, again, what we know that the slope is equal 0, but even if you forgot about it, you want to rewrite y equal negative 7 in slope-intercept form. Okay, since we don't have x, that means in front of x you can put 0, because 0 times x will give you 0, so we have 0x minus 7. So those two equations, they're equivalent, they are exactly the same, but here you guys quickly see that the slope, it's equal 0. Okay, that's the coefficient in front of x. Since there's no x, slope has to be equal 0. And y-intercept equal negative 7, which means you have on the graph 0, comma negative 7. So I will quickly graph this y equal negative 7. So horizontal line, 1, 2, 3, 4, 5, 6, 7. So this is negative 7. So horizontal line, you graph right here. So this is the y-intercept, 0, comma, -7, and horizontal line slope, it's always equal 0, because there is no steepness. Okay, so let's talk about example 2, a little more advanced. Given the equation (2x minus 6y equal -3), okay, we're going to do two parts here. I'm going to ask you to write the equation in slope-intercept form. Okay, so this equation, 2x minus 6y equal -3, this is actually the general form of the straight line, ax plus by equals c. Okay, so this is the general form. So general form, I mentioned, it's not useful at all, because from general form, you cannot tell me what is the slope and what is the y-intercept. That's why in part A, I want you to write the equation in a slope-intercept form. Okay. So what we're going to do? We're going to take that equation and solve it for y. When you will solve it for y, that will take you straight to the slope-intercept form. So we need to isolate y. So what I'm going to do first, I'm going to subtract 2x from both sides. And we will end up with -6y is equal -2x minus 3. And we need to isolate y. So now I'm dividing each by -6. And that will give you y, it's equal -2/6, which will give you +2/6x. Two negatives will give you +3/6. Of course, reduce your fraction. So 2 divided by 2, here both numbers we divide by 2 will give you 1. 6 divided by 2 will give you 3. So we have 1/3 x plus 3/6. This is just 1/2. Reduce the fraction by 3. So 3 divided by 3 will give you 1. 6 divided by 3 will give you 2. So this is the slope-intercept form. Slope-intercept form. Okay, so now when we have slope-intercept form, part B of this problem will be identify, like before, identify the slope and y-intercept. So now we're taking slope-intercept form and slope, it's the coefficient in front of x. So that's our m, x plus, and like you guys see, we have mx plus b, and this is b. So slope is equal 1/3 positive slope. So we already know that this line goes up. Y-intercept equal 1/2. Okay. So when you have general form like here in this problem, you cannot, it will be wrong if you say that slope is 2 and the y-intercept is -3, which is number stands by itself. Like you guys see, this is not correct. To be able to determine from the equation what is the slope, what is the y-intercept, you always need to rewrite this equation in a slope-intercept form. So that's always your first step. Okay, let's do example 3. In example 3, we're going to talk about graphing line using slope and y-intercept. So graphing a line using slope and y-intercept. Okay. So this is the problem. Graph y equal negative 5 over 2x minus 3. Okay. So this equation is in a slope-intercept form. You have that y is equal mx plus b. So we know that the slope is equal negative 5 over 2. Okay, when I have negative, I like to bring that negative to numerator. And y-intercept is equal negative 3. That means we have a point on the graph 0, comma negative 3. Okay. So what we're going to do first? So first, we're going to plot the y-intercept on the graph. So again, y-intercept is our point 0, comma negative 3. Okay. And second, the slope m equal negative 5 over 2. You should read that as the ratio rise over run. Okay. So in this case, what you're going to do, because when I have negative slope, I like to put that negative in numerator. So my rise, it's actually either when you have negative number, then you will go down. So that means go down 5 units. And I'm going down because of negative 5. And run means that you're running to the right or to the left. That's your horizontal. So here we're going to run, which is move. Since 2 is positive, so we're going to move to the right. 2 units. So what we're going to do, rise over run, we will go down 5 units and we'll move to the right 2 units. Because slope is rise over run. Okay, rise means you're going up or down. Again, since we have negative slope, because of that negative 5, that's why I'm going down. So let's just graph that. So I'm going to start with y-intercept 0, comma negative 3. So 0, comma negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 10, and so on. So this is negative 3. 0, comma negative 3. That's my y-intercept. And don't forget that slope, it's negative 5 over 2. So from the y-intercept, I'm going 5 units down. 1, 2, 3, 4, 5. And 2 to the right. So it will be 1, 2. And that will be my next point. Okay? Point 2, comma. Like you see, this is negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So here I have a point 2, comma negative 8. And you can repeat that, okay? You can go 5 units down, 2 to the right. So let me extend this graph. So 1, 2, 3, 4, 5. So -8, -9, -10, -11, that will be -12. So I'm going 5 units down and 2 to the right. So I continue this process. 5 units down. 1, 2, 3, 4, 5. It's actually -13 here. So 5 units down right here and 2 to the right. So I will be at 0.4 comma -13. And now I'm just going to create a straight line by connecting those points. Okay, so this is the equation of the line y equal -5 over 2x minus 3. Negative slopes, line goes down. And again, I didn't create the table values to find more points. I just used the information that the slope is rise over run. So I went down 5 units, 2 to the right. Okay, so maybe let's practice one more example like this. Let's do B. In B, we're going to graph y is equal to x minus 3 using slope-intercept. Okay, so again, we know the slope. Slope is equal to, when the slope is the whole number, you always want to write as a ratio. So 2 you can write as a fraction 2 over 1. Since the slope is rise over run, and we have 2 positive numbers, that means we will go up 2 units. And run means you're moving to the right or to the left, since 1 is positive, so we will move 1 unit to the right. Okay, so we're going up 2 units, 1 to the right. Okay, and of course, you're going to start with y-intercept, which is the point 0 comma -3. So let's graph it. Okay, so 0 comma -3, that's the y-intercept, 0 comma 1, 2, 3. That's the y-intercept. And now I'm going to use the information that the slope, it's 2, which means 2 units up, 1, 2, 1 to the right. And that's my next point, which I can easily read the coordinates, which will be 1 comma -1. And you can repeat that process. From this point, you will go 2 units up, 1, 2, 1 to the right. And you can continue 2 up, 1 to the right. Okay. And of course, you see that all those points create a straight line. And this is our graph, y is equal to x minus 3, positive slope. So rise over run, okay, like you see the slope, it's positive. How I know that I have to go up? Since 2 is positive, so I'm going up because, again, when the numbers on the y-axis increase, okay, we're moving up. And 1, the ratio 1 here, number 1, it's positive, so that means we're moving along the x-axis, so that's when we're moving to the right. Okay, hopefully no issue with graphing using slope-intercept form. Last one, graph y equal negative 1 over 4x. So solution, here you only have x, you don't have a number which stands by itself. You can so you can rewrite as y equal negative 1 over 4x plus 0. If you're missing number, missing coefficient, you can always add 0. And now this is in a slope y-intercept, which is y is equal mx plus b. So we quickly see that the slope, let's start with y-intercept. The y-intercept, it's 0, which means the point at the origin, 0, comma 0. And slope equal negative 1 over 4. So again, slope is rise over run. I have negative slope. When I have negative slope, I like to put that negative in numerator. So rise over run, since negative 1, it's negative, so I will go down 1 unit. And my run, it's positive 4, so I will move to the right 4 units to find the next point. Okay, so we're going to graph it, and when you're graphing, you always starting with the y-intercept. Okay, so the y-intercept, it's 0, comma 0, right here, origin, and now we're moving 1 unit to down and 4 to the right. So 1 down, 4 to the right, 1, 2, 3, 4. So that's my next point, which you guys will see 1, 2, 3, 4. So it's 4, comma negative 1 right here. And then you can continue. 1 unit down, 4 to the right, 1, 2, 3, 4. So we are right here. And if you need more, you will go 1 down and 4 to the right, 1, 2, 3, 4. Okay, so we have enough points to graph it and create a straight line. So you see this line, it's not so steep. Because slope is only negative 1 over 4, which is negative 0.25. Absolute value of negative 0.25, it's 0.25. So 0.25, it's a small number. That's why this line, it's not so steep. So this is the equation, this is the graph of the line y equal negative 1 over 4x plus 0. Okay. Okay. I think it's enough about graphing. Let's do the next example, which will be example 4. So example 4, we're going to determine whether two lines, whether two lines are parallel, perpendicular, or neither. Neither means they intersecting, but not at 90-degree angle. Okay. So let's just quickly review before we move to the example. So the same slopes or equal slopes means lines are parallel. Okay, so we talked about it before. Now, opposite reciprocal slopes means line are perpendicular. Okay, so let's do the examples. So for each pair of lines, we need to determine if they are, again, if they are parallel, perpendicular, or neither. Okay, so this is what we have. Y is equal to 3x minus 5. That's the line 1. And we have y is equal negative 3x minus 15. This is the line 2. Okay, so we need to decide with our graphing how those lines behave towards each other. So to know that, we're going to identify the slope. So the slope of line 1 is equal to 3. That's the coefficient in front of x. The slope of line 2, it's negative 3. So the slopes are not equal. The slopes are not, they are opposite, but they are not reciprocal of each other. So none of this condition which I review here applies. That means neither. The answer will be neither. Okay, so again, just remember, lines are parallel if the slopes will be equal. So let's say if M1 will be equal to 3 and M2, the second line will have a slope equal to 3. The lines will be perpendicular. Okay, so that's going to be the case. Let's say if slope 1 is equal to 3 and slope of line 2 will be equal opposite reciprocal, which is negative 1 over 3. So that's what we're looking. Since none of that condition apply, those lines are neither, which means they intersect but not at 90-degree angle. Number 2. We have y it's equal 5 over 6x minus 1/2. So this is line 1. Line 2 will have equation y is equal 5 over 6x plus 1/2. That's line 2. So here what happened? We see that the slope of line 1 is equal 5 over 6. Also, we see that the slope of line 2 is equal 5 over 6. Since those two lines have equal slopes, those lines are parallel to each other. So answer here will be parallel lines. The slopes are the same. Slopes are equal. Okay. Okay, let's do more. Just trying to give you all the scenarios. Next, we have x minus 3y equal negative 9. So that's the equation of line 1. And line 2, it's given by the equation 3x equal negative y plus 4. This is line 2. So in this case, because those two equations are not in slope-intercept form, so you don't know. Okay, what is the slope? Because we don't need y-intercept, but we need slope to decide how line behaves. So both equations are not in a slope-intercept form. So first, rewrite each equation in slope-intercept form. Rewrite each equation in slope-intercept form means solve each equation for y. Okay, work with line 1 first. So line 1 has the equation x minus 3y equal negative 9. We're going to solve for y, so we subtract x from both sides. That will cancel. We end up with negative 3y equal negative x minus 9. And you need to isolate x, so you divide each by negative 3. And that will give you y equal 2 negatives gives you positive. So we have x over 3 plus 3. And that x over 3 just rewrite as 1 over 3x plus 3. So this is line 1. And since I have line 1 in a slope-intercept form, I know that the slope of the first line is equal to positive 1 over 3. I'm going to do the same thing with line 2. So line 2 has equation 3x equal negative y plus 4. So I need to solve this equation for y. I'm going to subtract 4 from both sides, and that will give us 3x minus 4 equal negative y. And when you have negative y, that means there's negative 1 in front of y. So now divide each by negative 1. Okay, and that will give us y is equal negative 3x plus 4. So this is line 2. And the slope of line 2, it's the coefficient in front of x, which is negative 3. So now look what happened when we're comparing slope 1 and slope 2. So we see one slope is positive, one it's negative. Okay, so that's opposites. And they are reciprocal of each other, because the reciprocal of 1 over 3, it's 3. Or reciprocal of 3, it's 1 over 3. So those lines, so since the slopes are opposite means one positive, one it's negative, reciprocals, lines L1 and L2 are perpendicular. Okay. And one more example. This one is a little different. I don't want to skip it. It looks, probably you guys by now feel pretty comfortable about those type of problems, but let me give you one more example. So we have the equation of line 1, and this is x equal 2. And we have equation of line 2, which is 2y equal 8. So couple things here. The first line, x equal 2, this is vertical line, which intersect x, vertical line, and I draw horizontal, sorry. Vertical line, which intersect x-axis at 2. So this is the line x equal 2, okay? Now the second equation, the second line, of course you want to solve for y. So divide each by 2, and you're getting y is equal 4. Okay, y equal 4 is the horizontal line. Okay. So again, here, to be honest, you cannot really use the slope because vertical line, we know that slope is undefined. And for horizontal lines, you know that the slope is equal to 0. So how those two lines behave? Vertical line and horizontal line, they always intersect at 90-degree angle. So that they will be perpendicular. But if you guys don't see that, just graph it, okay? You can always graph it. So our x equal to our vertical line. So you're going to find 2 on the x-axis and just create a vertical line. So this is the line x equal to. Now the horizontal line y equal 4, just find 4 on the y-axis, 1, 2, 3, 4, and create a horizontal line which intersect the y-axis at 4. And like you see, this is y equal 4. Vertical and horizontal line, they will always intersect at 90-degree angle, which means those two lines are perpendicular to each other. Okay, we cannot really define that by slope because that's the different type of problem. But here from the graph, you guys see that vertical and horizontal line is always perpendicular. That is R perpendicular to each other. So when you have a case like this on your homework, you don't need to graph it, just use that information. Any vertical line and any horizontal line, they always will be perpendicular to each other. Okay. Next, example 5. So we practicing that slope-intercept form. Example 5. Example 5, it's about writing equation of line using slope-intercept form. Okay. So this one is about writing equation of a line using slope-intercept form. Okay. So this is what is given. Given the slope of a line equal -4 and the y-intercept is 0, -10. And we need to create the equation of the line using slope-intercept form. So slope-intercept form, it's y it's equal mx plus b, okay? M it's a slope, b it's the y-intercept. So everything is given. We know the slope of the line is equal to -4, so this is our m. And we know the y-intercept is a point 0, comma, -10. So -10, it's our b, y-intercept. So we'll just create the equation. So the answer will be y is equal -4x minus 10. So this is the answer. Okay, so here we didn't do anything. We just use the information, plugging it into the equation of the line in slope-intercept form. Let's do something a little more advanced. Write equation of a line using slope-intercept form. And having slope of 2 and passing through the point -3, 1. Okay, so solution. So we build slope-intercept form. So given information, we know slope is equal to 2. So we know that it's, so I can start building that equation. So we have for y is equal to x plus b. Okay. Now, you don't know the y-intercept. So you're going to use the given point, -3, 1, to find b, y-intercept. So use -1 to find b, which is the y-intercept. Okay. What are we going to do? We're going to take the equation y is equal to x plus b, and we're going to substitute x with the x coordinate of the given point, which is -3. We're going to substitute y, the y coordinate of the point, which is 1, and solve the equation for b. Okay, so let's substitute. X, we're going to substitute with -3, y with 1. So we have 1 equal 2. Replace x with -3, so 2 times 3 plus b. To solve the equation for b, so we have 1 equal -6 plus b. I will add two sides, and that will give us that b equals 7. So that means y-intercept it's equals 7. So now when we have a b, we're just going back to this equation and replace b with 7. Okay, so we have our solution is y is equal to 2x plus 7. So we have equation of the line in a slope-intercept form. Okay, So that's it from section 11.4. You guys have 6 different examples of problems involving slope-intercept form. Again, I really don't think that I will ask anything else on the test. So thank you for watching, and the next video will be from section 11.6.